So, a few weeks back I made a video about building a real Iron Man suit, and honestly, you guys absolutely crushed it. That video became the most viewed video on this channel, and your enthusiasm was incredible. Thank you for that. But here's the thing, Tony Stark's suit is only half the equation, isn't it? The real magic, the thing that makes Iron Man actually work, isn't just the armor, it's Jarvis.
You're welcome, I
what?
guess. Because I'm your nuclear deterrent. It's working. We're safe. America is secure. You want my property? You can't have it. But I did you a big favor. I have successfully privatized world peace.
Remember when Tony casually asks Jarvis to run diagnostics while he's mid-flight, or when Jarvis proactively warns him about incoming threats before Tony even notices? That's not just a voice assistant, that's a genuinely intelligent AI companion that understands context, anticipates needs, and reasons about the world. So today, we're answering the question, how close are we to building a real Jarvis AI? And spoiler alert, we're a lot closer than you might think, but also a lot farther than movies make it seem. Let me explain. Before we talk about where we are, we need to understand what Jarvis actually does. Because Jarvis isn't just Siri with a British accent, it's fundamentally different. First, Jarvis has contextual awareness across all domains. It maintains comprehensive knowledge of Tony's schedule, preferences, relationships, work projects, health status, and instantly correlates information across these areas. It doesn't treat each query as isolated, it builds a unified model of Tony's entire life. Second, proactive intelligence. Jarvis doesn't wait for commands. It anticipates needs, recognizes patterns, identifies potential problems before they occur, and suggests solutions unbidden. That's the fundamental shift from reactive tools to true assistance. Third, seamless multimodal interaction. Jarvis processes voice, visual data from cameras, sensor information, and digital inputs simultaneously. It understands not just what is said, but context from facial expressions, tone, body language, and environmental conditions. Fourth, real-time reasoning and planning. It performs multi-step planning across extended timeframes, understanding goals and autonomously determining the best path to achieve them without constant human direction. And finally, privacy-aware access. A Jarvis-capable system needs access to incredibly personal data. Communications, location, health information, financial data, behavioral patterns, all managed with appropriate privacy safeguards. So when we ask, how close are we to Jarvis? We're really asking, can we build something that does all of this seamlessly, reliably, and privately? Here's the surprising part. As of January 2026, we actually have many of the fundamental building blocks in place. We're at roughly 25 to 30% of the core capabilities required for Jarvis-like functionality. Let me break down what we've already achieved. Multimodal processing. AI has achieved genuine multimodal capability. OpenAI's GPT-4v, Google's Gemini, and Meta's ImageBind can simultaneously process text, images, video, and audio, extracting meaning across different data types. Healthcare AI systems now analyze X-rays while reading patient histories and listening to doctor consultations. That's real multimodal integration at scale. Extended context windows. Modern AI systems can now maintain context across enormous amounts of information. Claude Sonnet 4 operates with a 1 million token context window. That's equivalent to processing approximately 750,000 words, or about 5 times its previous capacity. OpenAI's GPT-5, launched in August 2025, has 400,000 plus token context windows. Think about what that means. These systems can hold the equivalent of several full-length novels in their working memory simultaneously. Long-term memory systems, AI systems, are beginning to implement persistent memory that bridges individual conversations. These use vector databases and semantic search to retrieve historically relevant information and inject it into current reasoning. Early implementations show 42% improvements in contextual relevance compared to systems without memory. This addresses one of the most persistent limitations of traditional chatbots, the inability to remember previous interactions across sessions. Your AI assistant can now remember that conversation you had 3 months ago about your travel preferences. Agentic AI and autonomous planning. This is where things get really interesting. Agentic AI refers to systems that can break down complex goals into subtasks, make decisions autonomously, and execute actions across multiple steps. Current systems like Anthropic's Claude can work autonomously on complex, open-ended tasks for approximately 5 hours with a 50% success rate. And here's the crazy part. AI agency is doubling in capability every 4 to 4.5 months. That means by the end of 2026, agents could handle tasks requiring approximately 40 human hours of work. On-device processing. Intelligence is moving from cloud-dependent systems to local, device-based processing. Apple's neural engine and similar specialized chips enable sophisticated AI models to run directly on phones, watches, and computers. This provides faster responses, offline functionality, and enhanced privacy. This addresses a critical problem. You can't have a truly personal AI assistant if all your data has to leave your device and travel to someone else's servers. Proactive AI emergence. Systems are transitioning from purely reactive, responding to prompts, to proactive, anticipating needs. Researchers at Carnegie Mellon demonstrated AI that turns everyday objects into proactive assistants, anticipating human needs without explicit commands. Financial services. AI already remembers client risk tolerance from 6 months prior and adjusts recommendations accordingly. Healthcare systems track symptom patterns across multiple interactions to identify trends physicians missed. So we have multimodal understanding, extended reasoning, autonomous agents, long-term memory, and proactive systems. That's impressive progress. But here's where reality gets complicated. Despite all this progress, fundamental challenges remain before a true Jarvis AI becomes possible. And these aren't small problems, they're core limitations of how current AI works. Challenge 1. Emotional intelligence remains largely unsolved. Current AI systems struggle significantly with emotional understanding. While modern systems can identify dominant emotions, fear, hope, disappointment, they fail catastrophically with nuanced or simultaneous emotional states. A person experiencing both anticipation and uncertainty simultaneously creates ambiguity that current systems handle poorly. AI cannot generate true emotion, it can only pattern match on emotional expressions. Think about it. Jarvis would need to recognize when Tony is stressed about an impending deadline versus merely focused, or distinguish between conflicting emotions that drive different recommendations. Current systems optimize for confidence scores rather than emotional authenticity, often producing plausibly reasonable but emotionally tone-deaf responses. Challenge 2. Causal reasoning and world models are missing. Large language models operate through what researchers call linear text symbol association, fundamentally different from human reasoning. They cannot model three-dimensional physical space, conduct dynamic causal reasoning, or accurately understand the real-time action feedback loops that characterize the physical world. This creates what's called cognitive brittleness. Systems generate fluent language that masks an inability to truly reason about causality, multi-step logic, or cross-domain understanding. A true Jarvis would need to predict consequences. If I adjust the suit's power distribution this way, it will increase responsiveness but reduce flight duration. Current systems lack the structured world model to make such predictions with genuine understanding rather than statistical correlation. Challenge 3. Genuine continuous learning remains elusive. Modern AI systems suffer from something called catastrophic forgetting. When learning new information, they overwrite existing knowledge, effectively erasing what they previously learned. Retraining on new data is computationally expensive and time-intensive. More fundamentally, current systems lack an internalization process. They don't gradually develop hierarchical understanding or robust abstractions the way humans do through cognitive development stages. Jarvis would need to learn from each interaction, integrating new information into a continuously evolving knowledge structure without losing what it previously learned. Today's static, point-in-time training simply cannot support this. Challenge 4. The enterprise versus consumer autonomy gap. By 2026, organizations can achieve reliable autonomy only in narrow, testable, verifiable systems. Enterprise AI requires three-layer governance architecture: a control plane for policies and permissions, an execution plane for agents and workflows, and a verification plane for correctness checks and outcome validation. A household Jarvis would face the opposite challenge: maximally open-ended domains with minimal verification infrastructure. You can't have a board of lawyers review every home automation decision in real time. These aren't minor technical hurdles. They're fundamental questions about how AI systems need to work differently to achieve Jarvis-level capability. So what do we actually have today that comes close? Several applications approximate Jarvis capabilities to varying degrees. Pika.ai is a free desktop assistant combining voice activation with Google Gemini AI, offering system control, app launching, and web automation. It's got a cyberpunk interface aesthetic that's honestly pretty cool. Google Assistant leverages Google's entire ecosystem for multimodal processing, voice commands, and smart device integration, though it's limited outside Google's services. Microsoft Copilot uses GPT-4-based integration across Office and Windows environments, supporting document analysis and workflow automation. Braina AI is Windows-focused with advanced voice recognition, custom automation scripts, and hands-free control through a freemium model. Mycroft AI takes an open-source approach for privacy-conscious users and developers. It's customizable but requires technical expertise to set up properly. These represent significant progress, but they remain task-specific rather than exhibiting true Jarvis-like integration and anticipation. They're impressive tools, but they're not yet true assistants. Think about the difference. You can ask Google Assistant to set a timer, but Jarvis would notice you're cooking. Remember that last time you made this dish, the sauce burned because you got distracted, and proactively offered to monitor it for you. That gap between responding to commands and genuinely understanding context to anticipate needs is enormous. So when will we actually have a real Jarvis? Based on current progress trajectories and unsolved challenges, here's the realistic timeline. Now, 2026, 25 to 30% capability. We have multimodal AI, long-term memory, and basic agentic tasks. It's impressive, but with narrow autonomy and still mostly reactive. We're in the cool tech demo phase. Enhanced multimodal integration and faster agents. Better at multi-step tasks, but still lacks emotional nuance. Your AI assistant gets noticeably better at understanding what you want, but frequently misses social cues. True proactive assistance emerges with limited emotion recognition. The system anticipates some needs reliably, but is still frequently wrong about context. It's helpful more often than it's annoying, which is progress. Controlled environment mastery, particularly in smart homes with genuine emotional awareness. It works well in bounded domains, but still struggles outside trained scenarios. Your home becomes genuinely intelligent, but taking it outside that context breaks the illusion. Seamless integration across life domains with human-level reasoning. This is when we might finally see something resembling true Jarvis, an AI that understands your life holistically, anticipates your needs across domains, reasons causally about consequences, and evolves with you over years. The longer timeline, 10 to 15 years minimum for true Jarvis, reflects not just technological hurdles but fundamental architectural rethinking required. We need to move beyond pattern recognition to causal reasoning, from static learning to continuous knowledge integration, from task specialization to general competence, from cloud-dependent to truly local processing, and from narrow autonomy to open-ended planning. What's actually happening now in early 2026? Enterprise organizations are moving first and fastest. The 2026 focus is multi-agent orchestration, coordinating specialized AI agents within real continuous workflows. Companies implementing end-to-end operational workflows with AI agents are discovering that the real value comes from governance frameworks, not raw capability. For consumer applications, the hybrid approach is winning. On-device AI for privacy-sensitive tasks plus cloud processing for complex reasoning. Google's Gemini Nano demonstrates this. Text summarization, reply suggestions, and transcription happen locally on Pixel devices for speed and privacy, while more sophisticated analysis remains cloud-based. The most realistic near-term Jarvis-like experiences will emerge in constrained environments, smart homes with explicit governance like automation rules, approval workflows, and escalation paths. Your home might anticipate your needs quite well by 2027 to 2028, but personal assistants handling the full breadth of your life require solutions to problems we haven't yet solved. So how close are we to a real Jarvis AI? Here's the bottom line, we're not close to Jarvis, but we're building the foundations faster than most people realize. We have the components: multimodal understanding, extended reasoning, autonomous agents, long-term memory, and proactive systems. What we lack is their seamless integration plus solutions to emotional understanding, causal reasoning, and continuous learning. If you're thinking about what's possible in 2026 to 2028, treat AI as a powerful but narrow specialist. Use multimodal AI for data processing, agents for multi-step workflows, and extended memory for context, but layer in human oversight because it's not ready to run unsupervised. If you're thinking about 2030 to 2035, expect specialized Jarvis-like systems for constrained domains. Your smart home, your personal productivity tools, these will anticipate your needs reasonably well in their domain, but fail badly outside it. If you're thinking about 2041, that's when we might finally see something resembling true Jarvis, an AI that understands your life holistically, anticipates your needs across domains, reasons causally about consequences, and evolves with you over years. Until then, we have impressive tools but not yet true assistants. Now, if you enjoyed this deep dive into Jarvis AI, you absolutely need to check out my previous video about building a real Iron Man suit. We explore the engineering, the materials, the arc reactor technology, everything that would go into making Tony Stark's armor a reality. That video became the most viewed on this channel for a reason, and if you haven't seen it yet, you're missing out. The link is right there on your screen. Because here's the thing, we might not have Jarvis yet, and we might not have a working Iron Man suit yet, but we're getting closer to both every single day. And that future, that's worth getting excited about. The future is already here. It's just not evenly distributed yet. Let's make sure we're ready when it arrives. And if you haven't watched the Iron Man video yet, you click on the left side of your screen to watch it now.